Hi guys, welcome to Geeks. In this video, we will discuss a space and time efficient solution to the binomial coefficient problems. So the problem says that we are given two parameters n and k, and we have to calculate the value of the binomial coefficient c n comma k. So for example, if we are given n is equal to 4 and k is equal to 2, our function should return 6. Now from previous discussions, we know that a binomial coefficient can also be written as nck, which is equal to n factorial upon n minus k factorial into k factorial. So in the previous videos we have discussed a few algorithms already. So the first algorithm that we discussed was a recursive algorithm. After that we discussed the dynamic programming based algorithm that took big O of n into k time and big O of n into k extra space. And later we discussed the space optimized solution that took only big O of k extra space. And in this particular video we will be discussing an algorithm that takes big O of k time and only big O of 1 extra space. So we just saw that c n comma k can be given by this expression n factorial upon n minus k factorial into k factorial, and when we expand these expression we get these terms in the numerator and these terms in the denominator. Now if you look closely, you see that the left part of the numerator is also present, the left part of the denominator is also present in the numerator. So we can cancel these out, and after simplification this is what we get. Now if you look closely, you see that we have exactly k terms in the denominator going from k to 1, and at the same time in the numerator also we have exactly k terms going from n to n minus k plus 1. So now in order to calculate this, we can simply run one loop that goes from 0 to k minus 1, and we can use that loop to calculate the product in the numerator as well and the product in the denominator as well, and we will finally have the value of c n comma k only after k iterations. Also note that c n comma k is equal to c n comma n minus k. We mention this because we can change k to n minus k if k is greater than n minus k. So for example, let us say we want to calculate 5c4. So we know that 5c4 is going to be same as 5c1. So if we calculate 5c4, our loop will run. Our loop will have 4 iterations. However, if we want to calculate 5c1, our loop is going to have only 1 iteration. So let us look at the C code. So we have our function binomial coefficient over here that receives the two parameters. So we begin by initializing our result as 1. And first of all we check whether k is greater than n minus k or not. If it is, we replace k with n minus k. And now we run our loop that goes from 0 to k. And at each iteration of this loop, what we do is we multiply result with the n minus I. Now, so n minus I represents the terms in the numerator. So when I is equal to 0, we are multiplying the numerator by n. When I is equal to 1, we are multiplying the numerator by n minus 1, and so on. Finally, when in the last step, when I will be equal to k minus 1, we will be multiplying our numerator by n minus k plus 1. And similarly, in the second statement, we are dividing the result by I plus 1. So we begin with I is equal to 0. So in the first iteration, we are dividing the value by 1. In the second iteration, we are dividing the value by 2, and so on, going to k minus 1. In the last iteration, we are dividing the result by k. So eventually when we'll exit this loop, we have the value of nck in our result variable, this variable. So we finally return that value. So this is space optimized as well as time optimized solution. So that's all for now. Thank you for watching. Please leave us your comments.